This video on the circumference of circles and the perimeter of sectors is the second in a series on measurement. In the previous video, we looked at the perimeter of polygons, including the conversion of length units. Please have a look at that video if you need to revise those topics. In this video, we'll look at the features of circles, what pi is, the circumference of a circle, the features of a sector, the perimeter of a sector, and the perimeter of irregular shapes. The diameter is the distance across the centre of a circle, identified in green in our diagram here. The radius is the distance from the centre to the outside of the circle, identified in yellow in our diagram here. I'll note that the diameter is equal to 2 times the radius. The circumference is the name given to the perimeter of a circle, which is the distance around the outside, identified in red in our diagram here. There's a special number that links a circle's diameter to its circumference, referred to as pi. Here's pi approximated to 5 decimal places. Pi has been studied by mathematicians for thousands of years. Before calculators, the fraction 22/7 was used as a good approximation of pi. Mathematicians have proven that pi is an irrational number. This means that there's no fraction that can be used that is exactly equal to pi. If the exact value of pi was written down as a decimal, the decimal places would continue forever. Pi is a mathematical constant that appears in many formulas relating to circles. It's also important in many other mathematical areas. A more precise estimate for pi can be found on most calculators and on the internet. A symbol for pi can be used to write an answer in its exact form. Here I have a table identifying the diameter and the circumference of circles. I've got 3 circles here. You'll find that if you divide the circumference of the circle by the diameter, approximated to 6 decimal points, we'll almost get pi. And I do that for those 3 circles there. And you'll notice that the number 3.14 approximately is where we get pi from. This tells us the ratio between the circumference and the diameter is 3.14, or 3.14 times the diameter is equal to the circumference. And that's how we get the formula for the circumference of a circle. So we write it, the circumference is equal to pi d. Let's find the circumference of a circle. So we know that circumference is equal to pi d. This can also be written as equal to 2 pi r, because the radius is half the length of the diameter. So if we're given a circle with a radius 6 centimeters, we write our formula, input our known value, and we solve. So in this case, the exact answer is going to be 12 pi. So the circumference of this circle exactly is 12 pi. If we approximate it to 1 decimal point, and we solve it, it's 37.7 centimeters. This is rounded to 1 decimal place. If we're given the circumference of a circle, we're able to use the formula to find out what the diameter and the radius are. So in this case, we're given the circumference equals 23 centimeters, and we know the formula equals c equals, or the circumference equals pi times the diameter. So we can substitute in our known circumference, and we can divide both sides by pi, and we get the diameter is equal to 7.32 centimeters. This is rounded to 2 decimal places. We know the relationship between the diameter and the radius, so the diameter is 2 times the radius. So if we divide both sides by 2, and we'll get the radius is equal to diameter divided by 2. So the radius is equal to 7.32 divided by 2 in our example, and the radius is equal to 3.66 centimeters. Here we have a number of sectors. A sector is formed by dividing a circle with 2 radii. So you notice on the 2 diagrams in the bottom left, a piece of the circle has been taken out, and we have 2 radii. The angle between the 2 radii determines the size of the sector. The perimeter of a sector is determined by calculating a fraction of the circumference of a circle, which is the arc length, and then adding 2 times the length of the radius. We've got 2 special types of sectors here, a half a circle or a semicircle, where the sector is 180 degrees, or a quarter of a circle, which we refer to as a quadrant, where the sector angle is 90 degrees. The perimeter of the sector is the sum of the length of all of its boundaries. So we get the length of the arc length plus 2 times the radii. In this case, we've written our formula out with theta, and r is the length of the radius. Here we have an example of the sector where the radius is 3 meters and the arc length is 270 degrees. So we rewrite our formula with our known values, and we can solve parts of that formula. So 270 on 360 is equal to 3/4. We've got 3/4 of a circle there. We get times in 2 by 3 and 2 by 3 to get 3 on 4 times 6 pi plus 6. That simplifies to 9 on 2 pi plus 6. Now this is our exact answer. If you ask for an exact answer, you've got to give it in terms of pi. Now we can't add 9 on 2 pi to 6, so this is the exact answer. And then we can use our calculator to solve it, and we get the perimeter of this sector is 20.14 meters. That's rounded to 2 decimal places. Here we have an irregular shape. It looks like it's got 2 sectors, one on the top and one on the bottom, plus 2 side lengths. So we can say the sum, or the perimeter, is the sum of the sides plus 2 arc lengths. In this case, the arc lengths, they look like they make a full circle. So we're just going to calculate the perimeter of the circle, which would be the same as calculating the perimeter of 2 arc lengths or 2 semicircles and adding them together. So we say the perimeter is 2 times L plus 2 pi r, which is the perimeter of a circle, or the circumference of a circle. We get the perimeter equals to 2 times 12 plus 2 times pi times 2. And the perimeter is 24 plus 12.57. So our perimeter of this irregular shape is 36.57 meters. That's it for this video on the circumference of circles and perimeters of sectors. In future videos, we're going to be looking at the area of squares, rectangles, triangles, the area of quadrilaterals, the area of circles, sectors, and ellipses. We'll look at the area of composite and irregular shapes, and then we'll go on to look at volume and capacity. Thank you.